I be out all night with the street lights. I get no days off on vacations. You inside, tell me what it be like. The fake love never did change me. I be out all night with the street lights. I get no days off on vacations. You inside, tell me what it be like. The fake love never did change me.
All these people falling off like they dominoes, chilling at the formal and designer clothes. I be politics.
What is up, you guys? It's your boy Mike from Balls of Fury. Welcome back to the channel. In today's episode, I'm going to talk to you guys a little bit about snake genetics. We're going to try to simplify it for you guys because I know when I'm on these videos, I'm saying, you know, pastel this, pied that, dream school this, dream school that. And sometimes I feel like you guys might not understand what I'm talking about. So I'm going to try to dumb it down a little bit for you guys, give you guys a little background on snake genetics in the most efficient way that I can, in the most simplified way that I can. And let's try to learn a little bit of something together. But to start, you guys, let's start off with what a normal ball python actually looks like. So this is a normal ball python. This is what you would find in the wild. It is also known as a wild type, obviously. But basically, this is the natural coloration of a ball python. You have the nice brown pattern with the black coloration. Just a beautiful, beautiful animal. And we'll basically explain to you guys what an incomplete dominant gene is and what happens when you breed it to a normal ball python. As you guys can see right here, I got two different looking ball pythons. This one right here is a cinnamon pinstripe ball python, and we still have our wild type ball python. Now, we'll focus on the cinnamon gene because the cinnamon gene is what we would call an incomplete dominant gene. Now, when you take an incomplete dominant gene like the cinnamon and you breed it to a normal, on average, half the babies will come out looking normal and half the babies will come out with the cinnamon gene. Now, if you take a cinnamon ball python and you breed it to a cinnamon ball python, you get what's called a super cinnamon, which is the complete dominant form of the cinnamon gene. So that's why a cinnamon ball python is referred to an incomplete dominant mutation, because its super form is actually the dominant expression of that mutation. So to give you guys an idea of what a super form actually looks like, this right here is a super fire ball python, also known as a black-eyed leucistic ball python. When you breed a fireball python to a fireball python, you have a 25% chance of hitting a super fire. And that goes for all incomplete dominant genes, such like the cinnamon that we talked about. You have that 25% chance of hitting a super cinnamon, or a pastel, you get a 25% chance of hitting a super pastel when you're dealing with incomplete dominant genes. Now, I'll post a picture of it for you guys of what the actual singular incomplete dominant form of the fire gene looks like. It is much different looking than the super form. And in most cases, you guys, when you do produce a super form, it is a much more dramatic looking animal than the actual incomplete dominant visual form of that animal. So take a look at this beautiful super fire while you guys also take a look at the fire mutation. Just an absolutely beautiful snake, man. Who doesn't love an all-white ball python? But that's a little background for supers for you guys, so you guys have a little understanding of how that works. And also, guys, like I said, when you breed a super to anything else or to a normal, on average, all the babies will be carrying that gene. So if we were to breed this girl to a normal ball python, all of the babies would be fire ball pythons. None would be normals. So that's pretty much how supers work. And down in the comments, guys, let me know, is this helping you? Are you keeping up with us? Are you understanding what's going on? Are you getting a little bit better grasp of the genetics? Let me know in the comments if I did a good job explaining this. And also, guys, let me know in the comments, do you like this style of videos? Do you guys like learning? Would you rather see snakes? I mean, I'm throwing a bunch of really cool snakes at you guys in this video, so you are getting to see some really dope snakes. But let me know, what do you guys prefer? Because I really want to have you guys engaged in the content, and I really want you guys to let me know what you want to see from me and what you want to see from our team. So down in the comments, guys, let me know what you're thinking. This next one is going to be a little bit confusing, guys, but this is really the only way that I can explain these types of mutations. What we're looking at next is what is called an allelic mutation. Now, an allelic mutation is basically where two genes will share the same protein on an allele on a strand of DNA. What we're looking at here is a highway ball python. Now, the highway ball python is an allelic combination between yellow belly and gravel. These are two incomplete dominant genes. Now, what happens when you breed the yellow belly and gravel, you get what's called a highway ball python. Now, the highway ball python can never be produced from a highway unless you breed it to something that has yellow belly or gravel in it. The only way you can make a highway ball python is having yellow belly on one side of the pairing or gravel on the other side of the pairing. You cannot create a highway ball python from the highway ball python itself unless you pair it to something that actually has yellow belly or gravel on the other side of the pairing. So this one's a little bit confusing, guys, but that's really the best way that I can explain it. Now, let's say that you have a highway ball python like I have here, and you breed it to something that doesn't have yellow belly or gravel. Basically, what happens is all the babies will be either yellow belly or gravel. Now, it's tough to tell with the yellow belly and the gravel gene because in their singular expression, they actually look very, very similar, and it's very hard to tell them apart. So just know that if you do breed your highway or freeway ball python or any other allelic combination, on average, all the babies will be either yellow belly or gravel, or whatever the allelic combination is that you're working, those genes will pass on to the offspring. But it will be 50-50. Half will be yellow belly, half will be gravels on average. That covers the allelic ball pythons. Let me know what you guys think and if you have any other tips on how I could explain that better. But that's really the best way that I thought of being able to explain it. So let me know what you guys think. Also, allelic ball pythons are freaking awesome. I mean, look at how dope our boy Hellcat, the highway ball python, is. Absolutely beautiful animal. Really excited. This guy is up to size to breed, so hopefully he'll start locking up with some of the girls that we got lined up for him. Let's talk about recessive genes next. Now, what we have here is a piebald ball python. This one also has banana in it, and then we're going to refer back to our normal ball python again to kind of show you guys what happens when you breed a recessive to a normal or a non-visual recessive animal. Now, basically what happens is when you breed a pied to a normal, all the babies come out looking normal. However, they will be carrying a copy of the recessive gene. In this case, it would be pied. Now, the reason for that is because piebald in its visual form is basically like the super that we talked about. It basically has two copies of the pied gene on its DNA. Now, this means that the pied will actually pass on at least one copy of the gene to every single one of the offspring. So guys, when you breed a visual pied to a normal, all the babies will be carrying a pied gene, making them het for pied, and they will come out looking normal. Now, what happens is, next is if you keep those babies back that are het for pied and you breed them back together, you will get a pied baby out of 1 of 4 eggs. So 1 out of 4 eggs, a 25% chance of hitting a visual pied when you have a 100% het to het breeding. So basically, guys, that is how recessives work when you breed it with a normal ball python. Now, if you breed a visual pied to a 100% het pied baby, on average, half the babies should come out looking pied and half the babies will come out looking normal, like this girl right here. But man, isn't the pied such a beautiful animal? This girl is deep in shed right now, but I absolutely love the pieds. And I'll show you guys next what happens when you actually breed a visual recessive to a visual recessive. Let's go ahead and put this little girl back. She's been doing a lot of demonstrating tonight, but what an awesome little group of snakes, you guys. So when you actually breed 2 visual pieds or 2 visual recessives together, you guys, what happens is all of the offspring will actually come out as the visual recessive that you're breeding. In this case, they would come out as visual pieds. Now, that's the best way to increase your odds of actually hitting on visual recessives is by breeding visual to visual. In this case, we have a pied right here. We have another pied right here. So if we breed these guys together, all of the offspring will be pied no matter what. Because like I told you guys in the last video, recessives are like supers basically. They carry 2 copies of the pied gene on their DNA, and they pass at least one copy of this gene to every single baby. So when you have a pied on one side of the pairing and you have a pied on the other side of the pairing, you're guaranteed to get 2 copies of the pied gene in each one of the offspring. Now, when you get into double recessives and things like that, we go back to the beginning with hets and double hets and all that stuff, which is a topic for another day, you guys. But these are pretty much the basics of snake genetics and ball python genetics. I hope that I was able to break it down a little bit for you guys so you have a little bit better of understanding of what I'm actually talking about when I'm spitting off pied this, lavender that, pastel this, orange dream that. It's could be confusing, so I hope this helps you guys a lot. If you guys enjoyed this style of video, let me know down in the comments. I hope everyone has a great night. Please do me a favor, you guys, smash the like button, smash that subscribe button, keep those comments coming. I will talk to you guys soon. Peace.